Okay, so this is a demonstration of the Integrated Urban Water Model, or IUWM. The purpose of IUWM is to forecast urban water demand and potential savings from conservation and use of alternative water sources over varying climatic conditions and land uses. So the Integrated Urban Water Model is a mass balance model that is able to estimate demand and then look at demand under different scenarios of water reuse, use of alternative sources, and water conservation, and be able to provide an estimate of water use under those scenarios. And then, as I already said, there's potential to look at different climate conditions and land use changes, population increases, to evaluate how that may also impact water demand. Okay, so one of the most beneficial components of the Integrated Urban Water Model is probably its interfacing with geographical information systems. So IUWM makes use of GIS layers on land use, population, like population census data and climate data, and uses all of that data to then estimate demand. So for example, land use and climate data are used to estimate outdoor demand, and then population is used in conjunction with water end use data to come up with estimates for indoor demand. And all of those things will be demonstrated as well. So the page that I'm on now is the documentation page for the Integrated Urban Water Model, and this has a description of the model and then really goes through a step-by-step process of how the Integrated Urban Water Model can be used and how different scenarios can be run, and all of the different steps to run the model, which I'll also be going through today. So I'll leave that to your reading, and for now I will go ahead and go to the model. Okay, so this is the main page for IUWM, and typically the starting point would be to choose a location of interest. I'm today going to be demonstrating the city of Fort Collins, and there's a couple of different ways that you can select your area boundary. So I'm starting by putting in the zip code for Fort Collins, and then you can, I'll show you, select an area using a rectangle, for example. So I could select this particular area, Fort Collins, and run an analysis on that area. I'm going to go ahead and cancel that, though, because what I want to do is upload a service area boundary. So there's all of these different ways that you can upload areas, including polygons, rectangles, the boundaries. And in this case, I'm going to upload a set of shape files that show the actual, or include the actual boundaries for the water service area for the city of Fort Collins. So this has now asked me to select files for uploading, and so I have in my computer shape files that represent the city of Fort Collins water service area boundaries. So I'm going to upload all of those. And this does take, when you do this, a minute or two. So for the sake of brevity, I'm going to just go ahead and go into another file where I've already uploaded that. So you can see we've got the same selection menu up here, and I've uploaded the boundary now, and then it comes up with these steps 2, 3, 4, and 5 here, where you can select your analysis subunits. So here you can run this, we could run this as a single unit of the city of Fort Collins water service area boundaries, where we would run just one single analysis, or we can break that up into blocks, block groups, tract, or county level. So I'm going to use block groups today, or you can also upload your own layer for that as well. For the population data set, like I said, we have automatically uploaded GIS layers for land use, climate, and population. So I'm going to go with the default, which is to use the census from 2010. Again, you can upload your own area. And for land use, I'm going to use the NLCD 2011 data set for that. And then for the climate data set, I'm going to use the automatically uploaded PRISM data as well. So now I click on Generate, and now what IUWM is doing is creating these subunits. It's extracting that data on population, land use, and imperviousness, so it gets imperviousness from the land use data set. And that population data just takes a little bit of time. It's very location specific. We have a pretty large area we've selected here as well.
So Sybil, we have a question of these are going into the live databases, right? These databases aren't in IUWM. It's going to get the databases from the national.
That's correct. So basically IUWM, through this ERAMS tool, accesses all of these databases and gets live data. So these get uploaded and updated as actually the people who maintain those databases update them, then the most up-to-date data would become available through this as well. So like I said, I think a really good attribute of this model is that automatic capability. Okay, so our data extraction was successful, so we can now close this little box. And we've got this Fort Collins area now, and we can go ahead and run that and get an estimate of water demands based on all of the default data. I'm going to go ahead and just open this up and edit or show you how you could edit to get your default data. Okay, so this is some of the parameters that go into estimating that. So we can see our current scenario up here is the default scenario. So that's the scenario that has all of the default values for running of IUWM, and the user is able to change those, but you can also get a pretty good estimate of demand without changing those. It depends on kind of exactly how much information you'd like to put in as inputs and how accurate the demand estimate you'd like it to be. Okay, so one of the first of those, which is really important, is the home profiles. So we have used the residential end use data to come up with these average homes that were built before 1999. Recently published in 2016, there was a study done on average homes again that determined household use at about 138 gallons per household per day. And high efficiency homes are about 107 gallons per household per day. So here we have 100% of the homes at this as average homes in 2016, and we've found that tends to be a pretty good average use profile for most cities, but one could modify those if they have more local information. We can also change these assumptions related to the average area irrigated, so that would be your based on the land use type. We're assuming for open space, for example, that there's 40% irrigated, low density 25%, and high density 0%. And there's other parameters down here related to stormwater and graywater that one could also change. So that would all set your kind of default demand. I also do want to just point out, you could, if you wanted to, go into these subunits, and for each of these subunits, so for example, there's a GeoID here, you could change the population number of households. This is the open space area, low density area, medium density area, and high density area. So again, if you had more local information or wanted to run specific scenarios in our subunits, which in this case is block groups, you could actually modify that data on your own, but there's no need to do that. So I've not made any changes here, which is the typical way that you would get a preliminary estimate. So I'm going to go ahead and save this, and then I can do a run to get our preliminary estimate of demand. So I'm going to, so your year range here is the years that you're going to use the hydrologic and climate data for estimating demand. So I'm going to go from 2000 to 2015 with this. So what IUWM is now doing is for each of these subunits or block groups that are selected within this entire utility water service area, it's estimating the indoor and outdoor water demands associated with those areas. Okay, so now we're loading results. And so what we can do, so this is now run, so we can close this box up. Now with this area, you can see each of those block groups that I was talking about. So you can click on those and see those, and actually it tells you the demand for each of those area population, what the area is, and population density. So down here now we can make some graphs. And I'm going to go ahead and graph that default scenario. Oops, I unselected that. Okay, so the way that I like to look at this typically is a monthly average. So it takes the average of those 15 years of demand that were estimated based on the climate data. And this is showing total demand. And so now we can see our gallons of water in each of these various months, and we can see the indoor demand in blue and the outdoor demand in gray. And then again, see by clicking these, we can actually look at the actual data for each of those different demands. And we can see, of course, that the demand over the summer months in our area is much higher than the demand over the winter months due to the high irrigation demand during that time. Okay, so now we have that monthly average demand. There's some features here that we can use in terms of normalizing that data in terms of either population. So this would be the gallons per month per person, or we can also normalize by area. So the gallons per month per area is what we now see per square mile, as it's indicated in this caption here. So also interesting with this, I'm going to take the normalization off, but I think a really nice feature here is, as well, is we can click on each of these individual subunits again and look at the demand in those areas. And so if you had actual data to compare to for those areas, then that could be really useful, or just to see kind of how your demand may vary all the way across a service area. So this is our kind of base estimate of demand, and then from there we can begin to run scenarios. So I'm going to go back up here now and create some scenarios. So how I do that is I go back into Edit, and now I'm going to go to Practices, and I'm going to start to create some scenarios. So the first scenario that I will create will be high efficiency homes. I'm going to name these in a way that we can understand what they are later. Okay. web page. So high efficiency homes is the scenario we're on now. So I'm going to change some of the parameters there. So I'm going to assume instead of 100% these average homes, I'm going to assume that maybe we have 20% average homes, and we've now moved into having 80% high efficiency homes. So 80% of the homes have adopted high efficiency fixtures at the basically the highest degree possible for our current technology for those various indoor fixtures. So we have that one. I'll go ahead and then also create another scenario where we'll look at gray water reuse. So I can keep creating these scenarios and then we can run them all at one time. Okay. So now we have gray water reuse, and I can go into practices, and I can say that we'll assume that at the homes 100% of the gray water is available for reuse. And then for this, we can use gray water for various different end uses: residential flushing, irrigation, combined flushing and irrigation, residential potable use, combined potable and irrigation, and then CII, or commercial, industrial, and institutional. So for all of these different alternative water sources, there are all of these end uses that are available to model. For this particular case, I'll assume that we'll do a scenario where people are using gray water for both combined toilet flushing and irrigation simultaneously, and we'll do a kind of extreme case just to see how this looks, where we say 80% of the population adopts that practice of flushing toilets with gray water and irrigating. And then the storage capacity per household, 200 gallons, is typically a good estimate for indoor, for residential gray water use, and that's per household. So if you had a multi-residential unit, for example, that would be 200 gallons of storage per residential unit in that larger multi-residential building. Okay, so we're going to I'll create one more scenario here, and then we'll go look at results. I'll do a stormwater use, or let's do roof runoff, actually. Roof runoff.
So Sybil, do you need to save your scenarios while you in between creating new ones, or can you just create all?
No, so I can just keep on going through this and then click save when I'm done. So just to illustrate that, let me go back and show the high efficiency home one. And if we go switch to that one, which is taking just a minute, see now the gray water is not showing up, and it has that change that I made to the home profile. So automatically it's saving all of those changes as long as you hit, as long as you're, any changes that you make to that while that's in this current scenario box, those are being saved. But then in order to save all of your scenarios to actually run the model, then at the end you've got to click save down here, which I'll show in just a minute. Okay, so let's get back to roof runoff. And with that one, so we'll go to stormwater use. No, it's switching. Hold on. Okay, so we're going to stormwater use. Here, this is the percent impervious available for capture. So since we're using the roofs only for roof runoff and not all of the driveways and roads in the area, this will be a fairly smaller percentage of the total impervious area. So I'll say 20% here. And just to keep this similar to what we did for gray water, let's go with 80% of the population adopting that practice for both combined flushing and irrigation. And we're going to have high volume storage tanks. I'm going to select 2,000 gallons, which is much higher than rain barrels, but has the capacity to really evaluate the full potential for water demand reduction related to roof runoff or stormwater harvesting. Okay, so now I've created those scenarios, and I'm going to go ahead and save all of them, so it saves them all together. All that scenario data was saved, and then we can now run those scenarios. And again, I'll select a year of 2000. And the default scenario didn't take time to run because we already ran that one. So it's not running that again because we made no changes to that scenario from the last time. So now it's just running all of these different scenarios for the high efficiency home, roof runoff, and gray water reuse. So high efficiency home is now done, and everything is now done. We can now take a look at how this looks. Okay, so I'm going to close this box again, and I'm going to go ahead and graph all of our scenarios. And again, I like to look at the monthly average. And now we can see we kind of have a lot going on with this graph, a lot of different colors now. So we've got our default indoor, default outdoor, high efficiency home, indoor and outdoor, so on and so forth. So one really nice feature I think here with these graphs is that we can click on these to just compare them together. So let's first just look at our default scenario and then switching over to the high efficiency homes and what change that caused. So what I can do here is click on all of these different gray water and roof runoff scenarios, and those go away. So now we can see what happened with that scenario. The indoor demand is in light green for the high efficiency scenario versus blue for the default scenario, and now we can compare those side by side and see that our indoor demand decreased, and that resulted in a decrease in overall demand during the summer months, but there was really no impact then to the outdoor demand. Now, say we want to look at gray water reuse. So we get some further reductions from the high efficiency homes and total demand during these months. So maybe now we want to take out our default demand, for example, and just look at how did the high efficiency home scenarios compare to the gray water reuse scenarios. And then we can even add back now our roof runoff indoor and outdoor demand and see what the impact was there. So just to kind of illustrate one point related, because let's now take away the high efficiency ones and put back the default. So one thing we can see here is that we were using gray water or roof runoff to meet toilet flushing demand. So you can see an increase in indoor demand for each of those scenarios, a more sharp increase for the gray water reuse, and then we also see outdoor demand associated with both of those scenarios compared to the default as well. So I think that that shows you how you can run some different scenarios with IUWM and be able to evaluate the water demand reduction associated with those various uses. With those different scenarios. Yeah.
Is the demand, the outdoor demand shown for the roof runoff and the gray water reuse, is that the demand outdoors from potable water, or is that what's being used from the gray water and roof runoff to meet the air?
Okay, so yes, so that's a good question. So what we see here now is demand for municipal potable water. So it's not the total demand for water didn't change. What did change was the demand for potable water, because we were replacing that with the with either the gray water, the alternative source being gray water or roof runoff.
Okay,
now,
thank you. Helpful.
Sure. So one thing I would like to point out too, I mentioned the capacity of IUWM to evaluate things under different climate scenarios and land use change as well. So I would just like to kind of quickly show where you can do those. So for example, we have climate here. We could create a new scenario where we have climate, and with that one now we can investigate a temperature offset or a precipitation scaling that would, and how that would impact demand. So what we'll do here, I'll have I'll say the temperature increases by we'll go with 5% increase in temperature, and then an 8% decrease in precipitation. Just kind of see what happens here. Let's go 8% decrease in precipitation, and I can now save that as well. And I can run that scenario as well. 2000 to 2015 again.
Well, I was going to ask, when you're running for a time frame like from 2000 to 2015, is the model bringing in different land use maps too, or is it just the climate map? Do you know?
It's the climate data that's changing for that historical. So the idea is to get a projection of what we could expect on average, and we use typically 15, 20 years of hydrologic data to kind of get the entire spectrum of what could happen during you know, lower rainfall years, higher temperature years, et cetera. So it's really the climate and hydrologic data that it's using historical data to get kind of to that projection of a monthly average value that you could expect. And then you can predict out future scenarios by either changing the land use or changing the climate in terms of temperature like we've just done, and precipitation. Does that make sense?
Yes, it does. Thank you.
Yes. So, okay. So last thing we'll show here, I'll just graph the default scenario next to climate. We can look at that. And look at this monthly average data. So we can see an increase in outdoor demand associated with that temperature, decrease in temperature, and increase in temperature and decrease in precipitation. That we get an increased irrigation demand then associated with that. So I think that now shows all of the different types of scenarios. So same goes for land use and population. You can run different scenarios there, and there's a pretty extensive amount of detail within the documentation page on IUWM on how to do that. So I will go ahead and conclude this here unless there are any more questions.
Nope, that was good. Thank you.
Thank you.